Welcome everyone to our session on Introduction to Hyperledger Indy. This session will provide attendees information on how the communication on internet will change with the introduction of layer of trust and data authorization in the hands of people. With that, I would like to introduce our speaker for today, Aashish. Aashish is currently working as a senior blockchain developer for McKinley Rice and supports the Korean teams. His previous projects includes model creations that support multiple ledger in Hyperledger Aries. Over to you, Ashish. We are looking forward to today's presentation.
Hello everyone. My name is Aashish, and let's quickly start the session. Let me just share the screen. All right. My screen is visible, right, Anjali?
Yes, it is visible, Ashish.
Okay. So let's head over to what exactly is Hyperledger Indy and what is this blockchain algorithm that we are talking about, right? So the topics that are going to be covered today is the self-sovereign identity, DIDs, and Indy ledgers, sovereign zero knowledge proof model, and what is exactly the identity and verification. But before we move on to Hyperledger Indy, let's understand why and what is Hyperledger Indy and in what condition that they were so moved to create something like that and how it is useful in blockchain. So in the normal scenario in the Web 2.0, that how the internet was working, the website that the end user, people like us who are trying to log in, we use something that is either social authentication or the website's own login system. So whatever data, whatever information that we use to type in to create our authentication is something that has been tagged with the cookies and the metadata. And that is how the most ad agencies are working together to create some more interesting to show some data to the end user. But the end result being that the end user is getting exploited. Days and days pass, and all of the data is getting processed by those companies, which in turns could be deadly for the end user itself. Because internet doesn't have any trust in between, any layer of trust in between. You never know who is the person on the other end who's going to use your data. That is when a layer of trust becomes necessary, which is actually achieved with the help of blockchain. When we talk about blockchain, we think that there is some database and some distributed ledger, but actually with the help of that ledger, we can also establish a trust layer with this SSI model. So coming back to the first topic of the SSI model, this is something we called as self-sovereign identity. Now, what is self-sovereign identity? It means that each and every part of the data that user holds is actually is completely in hands of the user and not in the hands of some company. If I'm trying to log into Google, if I'm trying to log into Google or any other party, if I'm creating any data, I have complete information of that data in my own hands, and it is me who has this authentication, who has this power that I can share that data to whoever person that I want, that I authenticate. It is not that without my consent that data will be shared, and I won't even know who it is shared with. So this is something is there that is we called as self-sovereign identity model. So and in for establishing the self-sovereign identity model, when we talk about Hyperledger umbrella, there is something we called as Hyperledger Indy. So Hyperledger Indy was developed because uh, in terms of blockchain, BC Sovereign is one community that wanted to establish their own ledger. And they came up with a project that we will term this project as Hyperledger Indy, as Indy is the name of the ledger itself. It provides us with the tools and the libraries itself so that we are able to establish the theoretical model in practical use and can establish a layer of trust in between internet and the participants itself. For creating the Hyperledger Indy, we also have to move forward with the layer of authentication, with the layer of security itself. And that is when they also created one separate. It initially it was combined within Hyperledger Indy itself, but because it has users in each and every it in a lot of blockchains, so they created a different project that is Hyperledger Ursa, which is just a simple Hyperledger umbrella library used for cryptography. The third one is something we call as Hyperledger Aries. Now, Hyperledger Aries is basically an infrastructure. It gives you an infrastructure to work upon Hyperledger Indy itself, to work upon the tools. And because the end user doesn't have to be technical, he needs to have some easy access. So Hyperledger Aries give you that framework, that architecture, so that you are able to perform and establish the model by using the Hyperledger Indy library. So coming back to what exactly is Hyperledger Indy used for and where exactly it is coming from. So Hyperledger Indy, when we talk about, it is used for creation of blockchain. So Indy is a ledger in which all those modules are named. For example, if you're trying to understand blockchain, there will be some storage where your data will be kept, your data blocks will be kept, and it will be encrypted. So Indy comes with a lot of features that you have. For example, you have wallet services, you have credential services, which is what you have in the CLI services, which is what constitutes in this blockchain form. And when we talk about Hyperledger Aries, then over this blockchain, we needs to have some end users. We needs to have some agents that are going to represent them in the form of entities. So Hyperledger Aries is what we use to actually interact with those blockchain. So if I try to compare that, what was the previous architecture of the internet that was being used and what should be, what will be the upcoming architecture with Web 3.0 and SSL. So when the websites, when the end user is going to log into the websites, for example, if the websites have social authentication, then the end user is actually going to use the social authentication if he has created his account on Google or Gmail, and then those access will be authenticated, and then it can move on to the usage of the websites. So basically, over here, the websites, they are acting as a form of verifier, and the social authenticators, for example, Google or Facebook or whatever, they are acting as a form of issuers. And the end users, they are basically the holders who are going to hold all the data within them. So that is what the verifier, holder, and three issuers. These are the three entities of the basic SSI model. So verifiers, they will be trying to verify your data. The issuer, they are going to issue your data, and the holder, they are going to hold their own data. And then what they in this complete three entities, there comes a process which is something called zero knowledge proof. And why do we use this, and how is this holder is going to have the complete information with itself that whether he's going to share the data or not, right? Because he needs to have the complete each and every ownership of the data with himself and not with the company itself. So that is where some blockchain comes in picture. Okay. So let us assume with one example. Let us have with one example that suppose there is a very common and a good use case that we try to explain, and that is something called driving license use case. So in driving license use case, there are basically three entities: the person who is being issued the driving license, the government who will issue you the driving license, and the traffic police officer or the policeman who's going to verify your driving license. So when the government will be issuing your driving license, that is the issuer part. You will be issued the credential, and from the verified side, the policeman, that will be the verifier who's going to verify your credentials, that whether the credential, the driving license that you have been provided or you have provided to them, is it valid, whether it has revocated or not, whether it is fake or not. He don't know, you don't know, right? How is he going to verify them, right? So that is when the verifier comes in picture with the, so he can verify it with the use of blockchain itself, right? So there are a lot of concepts when we are talking about SSI model, DID creations, Indy ledger. But one of the concept, that is something we called as schemas and credential definitions. And this is one thing that we have schema, and there's another thing that we have. We call something as credential definitions. So what exactly is the credential definition? All right. And third thing that we have is we call as issue credentials. All right. So let us assume that we are trying to share, we are trying to create some kind of certificate, right? So we have a PLSQL data, or we have a relational database which have some rows and some columns in which to try to input that data, right? So when we are talking about the column name, it is something represents that the entity is going to be present over there, right? For example, you have one job certificate which is going to have some dedicated fields. For example, it is going to have the employee's name, it's going to have the employee's maybe photo, it is going to have employee's previous career history, his own address, his phone number. So these are the fields that the employees will be certificate will be having. Now, when we're talking about the schema, in order to issue those credentials, in order to give the holder the power, we have to create some kind of schema so that on that same schema, we can issue that to multiple holders. Just related to the driving license example, so that when the government will be issuing you the driving license, they would have created a schema for you, because for each and every driving license it has the same description. The values of the fields could be changing, but the number of fields and what those fields are will be the same. So that is what schema is. You create your schema according to your use case, and then you proceed with the credential definition. Now, when we come to credential definition, what we have is, um, for credential definition, um, when we talk about schema, so there is this complete architecture of basic model that we have created. But when we are talking about credential definitions, what we are telling them is that from the schema, when we are trying, when we will be trying to issue uh, um, certificates on the basis of the schema to the holder, we also have the power to issue uh, add revocation feature or not with the schema, and whether we can bind multiple schemas in one credential definition. So we basically add some kind of version to it. That is what credential definitions come into picture. So before actually issuing those credentials, credential definition takes schema as an input, and it's tried to create its own ID on the ledger. So when the issuer, the schema is created by issuer, and when the schema is created, it is being posted to the blockchain. The credential definition ID as well is being posted to the blockchain, because that is from where all the entities are going to grab the data from. So when you have credential definition ID created, that is when you will try to issue those credentials to the holder. But the first step that we do before the creation of anything else is we try to create some connection. So let us suppose that let us take it forward and let us understand that in the real use case scenario, how we will be using it is, for example, let us say that there is some kind of digital wallet application, payment application, and there is some scan code. So whenever you are trying to scan code and you want to pay the end user, right? Let us say it is $100 you want to pay with the scanning of the code. The first thing that you are establishing is the connection between your payment merchant and you in your digital wallet, because you want to specify that I want to give the payment to this particular end party. And after that, you specify that those are the $100 or $200 that you want to send, right? But the first thing is the connection, right? So that is when the issuer and the holder, they try to create connection with one another, right? So, and when they are trying to create a connection, they want DIDs to create the connection. That is when the concept of decentralized identities comes into picture. The second point of DID. So what DID is, it is something, it is called as decentralized identifiers. So it means that all the entities present that will be working in the Web 3.0 internet, they will have their own DIDs. So what DIDs is, DIDs, they have something called a scheme name, that is DID, that is going to specify on which blockchain are we working upon. The second thing that we have is we have something called DID schema name, method name. So there could be a lot of DIDs registered. First thing is, first time when the DIDs got created, the concept, it was created with sovereign and it was created with Bitcoin. Now the concept has moved forward and you can also register your own DID, right? And then the third thing that we have in this complete DID string is actually the DID unique identifier. It can be a random number of digits. So this complete thing is what constitutes a decentralized identifier. So when we're talking about issuer, because the issuer needs to be needs to have their DIDs um, sent publicly listed to the blockchain itself. So their DIDs are called as public DIDs that everybody can see. But when we're talking about holder, so holders, they don't have to be in the blockchain directly. They don't have to connect to the blockchain directly. They just have to connect to the issuer. So what they will be having is they will be having the pairwise DID. Just as in public key and private key, we have pairwise DIDs and public DID and private DID for them. So, and again, when it comes to the verifier, he also needs to be having this DIDs registered in the blockchain. So that will also be a public DID. When we're talking about, let's move forward and let's establish the fact that we have all like created the connection between the issuer and the verifier and the holder. Now, when we have established the connection, the second step that we have to move forward is that issuer needs to be ordered to create some kind of schema in order in um, let's answer the questions after the answer session is done. I hope that is fine. Okay. So once the schema it is done, then we move to the credential definition parts and we create our own credential definition IDs. Once this ID part is done, then we try to move forward and then we try to actually issue those credentials to the holder. Suppose that we have actually issued these credentials to the holder, then what comes in picture is the verifier part. That is we call this present proof. So this present proof is this naming is coming from the legacy code APIs that they have named, that how the terminology they are using. The present proof is something is those APIs that verifier will be using in order to request the holder that share me some presentation, share me some proof that you have this certificate, and I want to verify that the certificate that you are trying to share with me, whether that certificate is valid or not. And how he's going to validate it is through blockchain. That once holder share it to the verifier, is going to verify it through blockchain itself. So let's move forward and let's just show this complete form in the form of the demo controllers itself. Let us show you how the demo controllers are something which have been provided with from the Hyperledger community, because they wanted to demonstrate how the SSI model comes and works in picture. So they created some agents for you, some entities for you. So I'll be showing the demonstration with the issuer and the verifier itself. The verified demo controller name will be, sorry, the holder demo controller name will be Aries, and for the issuer, the demo controller name will be Favor. Let's move forward. Let's share the screen. Okay. So this is where the demo controller's code is done. They have a repository for Aries Cloud Agent pattern. Inside demo, you will find that there is some code written for demo controllers. So this is the basic command that this is a command that you run that in order to start the Docker containers and give them the input parameter for the ledger you want, right? So I'll be trying to run this demo and I'll be running the holder image first of all. And on the right hand side, I'll be running the favor image. That will be in an issue set. We will try to go through the logs one by one. Okay. So the issuer is getting started because the demo controllers come just in the form of demonstration. So a lot of things are hard coded. A lot of things are there which are pre-planned, right? For example, the issuance of schema and the credential definition and some predefined schema structure. For example, day, date of birth, time, degree, and name. These are predefined in order to show that how the things are going to work. This is the basically scan code. If I just clear up the screen, you will see that it is a scan code. So there is a concept of mediator agent. I cannot use it directly over here to scan it, but if we have set up some kind of mediator agent, then we can try to connect it with the mobile itself. You can open some kind of application, I would say forensic application. And if you would try to create a connection with this scanner or with this scan code, you will be able to. In the meantime, let's first of all try to establish the connection between the left side, that is A list, that is the holder, and the right hand side, that is favor. So once this agent is started, this is the favor agent, this is the issuer agent, you will see that the blockchain that we are using is the BC server. Now this is some organization that started working upon long time back when Hyperledger Indy was just a concept. So when the theories were being established into a product, pieces of them started working on it and created some form of
Ashish, sorry, we are not able to see the demo. We are still seeing your draw.io screen.
okay. All right. Let me share it. Let me share it again. Are you able to see now?
Yes, can see now.
I'm so sorry. All right. So I'll start it again. On the left hand side, you will see that in this demo, this repository, you have I'm starting the holder that is the A list. Named alias, and on the right hand side you will see that there's this issue that is called favor. So once we start this demo controllers, these are predefined, right? These are predefined. They have all the configurations freely set up, and there are only some inputs that you can give to these demo controllers. For example, one of the input that I give is I told him to connect to some particular blockchain itself. So BC sovereign is one ledger that I want to connect to, and I want to connect to the testnet. So I gave this string for test BC sovereign VONs.I. Another thing that in order to create the connection and proceed with the SSI demo, we need that schemas and credential definitions on the ledger. So because the demo controllers come to the predefined configuration, so you will see that these are the attribute names. These are the schema. This is basically the schema attributes names, which is being pushed to the ledger. And you will be seeing that, okay, the schema ID is created. And same happens with the credential definitions. You will see from this particular schema ID, taking this schema ID as an input, you are able to see the credential definition ID that is being created. Now let's proceed and let's try to create a connection. So when we are creating a connection, okay, this is the scanner code that I was talking about. So using this scan code, if there is a mediator agent, this is some kind of medium that is set up so that even through mobile, we are able to scan code, the end user can converse it through mobile itself. But right now, because of the mediator agent is not set up, we'll try to create the connection using this invitation data. Okay, this is the DID connection invitation exchange data that we try to copy, and then we'll try to send this data to the invite detail sections of Alice. Now, once we copy this data, you will see that the connection is perfectly established between the issuer itself and the holder itself, and the DID communication is successful. You will see that if you want to send a message to Alice, to issuer, that is Faber, you can send it. And of course, over here you can see that the message is received from the issuer side that you have sent. Now let's proceed with the issuing of the credential. That is the fourth step when we're talking about the SSI model. So this fourth step, issue credentials, it will actually it will create the credential offer for you, and then it will send those credential offer to the holder itself. The holder will process it and then it will store it in the wallet. So you will see over here that when it is sending the credential issued, the state is done. From this 17th point, issue credential to X. Now, when the state is sent to 17 and then it moves to the 18, it is showing that how the step-by-step process is moving. It is trying to tell the crossway communication between both the issuer and the holder agent. So the stored credential, when the credentials are sent to the holder, it is being stored in the wallet and the ID is created. That is how we term that, okay, the credentials was successfully issued from the issuer, but it is also successfully stored from the holder wallet as well. So that if the holder has stored it successfully, he is able to send it to the verifier as well. Now the issuer can also be the verifier. So we'll try with the same demo controller that he will be sending the proof request. Point number two to the holder in the case of verifier as a verifier agent state. So if I want to send proof request to the holder, then you will be seeing that I'm able to perfectly send it out, and the JSON that is being sent from the issuer side to the wallet, they have created the proof for that particular request and they have sent it to the issuer part. And then you will be seeing that the presentation state is done from issuer. That means that it is successfully verified. There is no the credential that was being issued by the issuer is completely authenticated, and it is valid uh, from the in that is being issued in the holder's wallet. So this is something that SSI model works. And when we okay, so 1 second, and let me just share this screen. Yeah, so you can see the draw.io. Anjali, hello.
Oh, yeah, sorry, I was on mute. Yeah, I can see it.
All right. So when we are talking about the layer of trust, we are talking about, okay, the complete information is in the hands of the data. With these demo controllers, we are trying to establish the fact that once, let us say, some party has issued some kind of login system, right? Let's say that there is some website called, let us name the website called Leo, right? Leo. And Leo has its own login and sign up application, right? So let us say that this particular website has issued our own credentials to log in into their particular website, right? And they are working on a centralized blockchain, right? Sorry, decentralized blockchain. So Leo, there could be multiple entities such as Leo, right? And the holder could be logging into multiple websites from the same application, and he will be sending the data with its own authentication. So he will be having control over complete data that he will be sending. So when I shared the screen, and I showed and I told you that there are some predefined schema structures, right? So there are some predefined schema structures. Let us say it is name, and then we have mobile number, we have age, we have address, right? And let us say that we don't want to share all this information, right? We only want that without showing our own driving license, the traffic policeman is still able to establish the fact that my driving license is valid. That could only be established with this particular model, because over here, how the policeman is verifying is through the blockchain itself. And if you want to specifically show some data that I will be showing my name, right? You can show it. If you don't want, you won't be showing it. So that kind of um, feature, that kind of power in the hand of the holder comes with this Hyperledger Indy SSI model. That is how why it is being created, and that is why it is being utilized, and people are trying to draw some projects over it and try to utilize it in new World Wide Web 3 platform. If you have any questions, you can definitely ask me. Why does a verifier need a DID? All right. Anjali, is there any way that we can unmute all the participants?
Yeah, Ashish. So everybody is yeah, welcome to attend this one. They just need to register for the event.
Okay. Okay. So, all right. So, why the verifier needs a DID is that in order to send, in order to verify this holder part, they also need first of all to create the connection so that the holder can send the two requests. So that is one point why they need DID, because of course they are a part of the entity DID model. So they need a DID in order to communicate and create and have a DID com exchange participation. But why does it needs to be a public DID, right? So when the verifier is actually verifying the credentials that is being issued to the holder, right? Those that verifier information, that complete DID information is being utilized from the blockchain. So how would I know that the end person who is trying to verify me is actually a legal, is coming from the legal entity, right? How would I know as an end user? How would I know that the traffic policeman who is trying to verify my credentials is in fact an actual traffic policeman working for the government? How would I know that? Right? So the verifiers, they are registered into the console, into the platform through legal process. That is why their DIDs are public. That is why they need a DID in this platform to have their own identity. I hope with this I have answered your question. Is
Thanks,
there
Ashish. So is there any other question? Feel free to add it in the Q&A box. So yes, Anjal said that her question has been answered.
thank you.
All right, any other questions? I think if not, thank you, Ashish. I think the session was really wonderful, and the recording will be available in YouTube Women Who Code YouTube channel in a few days.
And there is one more thing that I need to add. This raw.io file is basically is what something that there is a common comparison that has been done between Web 2.0 file and Web 3.0 file. And what are the entities and why, how are they, where are they trying to create the connection that is being established. Also, you will be having these useful links that if you will try to figure out that what exactly comes up when we are trying to work upon this zero knowledge proof and SSI models. These are some very useful links in order to establish that how the whole platform is working. So there will be one network that has been created. The ledger that I was using in the demo controllers, these are the link for the ledgers. The last point number 6. You have the open source code libraries for Hyperledger Aries and Indy. The links have been shared. You have the Transit wallet, for example, if you want to use the mobile agent in order to create your own, in order to communicate through mobile. So you can download it definitely from Play Store, and also it is available on iOS. You can try to pay in holding and get your own verifiable credentials. And if you want to register your own DID, and if you want to check what kind of specifications are mentioned, as DID will be named as a, it is going to be enabled in the Web3 platform very soon. Then you have this link for decentralized identifiers. That way you can go and check out all the specifications for yourself. Thank you so much for the session. And thank you, Anjali, for presenting me with this opportunity to share this knowledge with others.
Awesome. Thank you so much, Ashish. And I definitely know that all of these information is not readily available in the internet. And thank you for curating this for our members. I really appreciate it. And thanks
Thank
to
you.
all the attendees for attending today's session. All right. Thank you.